Hello guys, welcome to my YouTube channel. In today's video, I will be revising Science Paper 2, Examinations Council of Zambia, Examination for General Certificate of Education Ordinary Level, 1st August 2019. So this is the paper that was written in 2019, and I already did a revision of Part A and Part B, and in today's video, I will be revising Section C. So if you are new to this channel, you are most welcome, and on this channel I teach mathematics, science and biology, and also revise past examination papers just as I'm doing now. So if you never watched the first part of this video, you can click on the link here to go and watch it there. So let's go straight into the revision. Alright, so this is section C, 20 marks. Answer any two questions from this section. Write your answers in the separate answer booklet provided. C1, the questions below show the thermal decomposition of the nitrates of three metals represented by W, X, and Y, not their real chemical symbols. Alright, so we are told in these equations we have here, these equations represent actually thermal decompositions of the nitrates of three metals. Here, metals X, W, X, and Y. And we are told these are not actual symbols of the metals, they're just representing. So here we have this equation where we have W nitrate being heated because thermal decomposition is heating. So W nitrate being heated, giving us W the metal plus nitrogen dioxide plus oxygen gas. Then we have also X nitrate being heated, giving us X nitrite plus oxygen gas. Then we have Y nitrate being heated, giving us nitrogen dioxide plus oxygen gas. So I can see this equation to be strange because there's no way we can start with the metal on the reactant side and not having the metal on the product side. So I consider this one as an error on the examiner's part. So let's see what the questions are. A says, which one of the three metals is the most reactive? Give a reason for your answer. 2, least reactive. Give a reason for your answer. B, which one of the three metals is likely to be sodium? Then C, which one of the three metals is 1, more reactive than zinc? Give a reason for your answer. 2, less reactive than zinc? Give a reason for your answer. D, state the chemical test for oxygen. So let's start answering this question right away. So before answering this question, remember, when we are talking of thermal decomposition of metals, what you should know is that, number one, the nitrates of most reactive metals are hard to decompose into their metals, or are hard to reduce into their metals. So when you hit a nitrate of a most reactive metal, you are likely to get the metal nitrite plus oxygen gas. However, the nitrates of moderate reactive metals, when they are heated, they decompose into metal oxide, nitrogen dioxide plus oxygen gas. And then the nitrate of less reactive metals, when they are heated, they decompose into the metals themselves plus nitrogen dioxide plus oxygen gas. So now, having that already in mind, what you should know is that on these, we eliminate this because this one is really wrong. So on this one, which one of these two equations represent decomposition of a nitrate of a most reactive metal? It is this equation number 2. Because equation number 2 contains the metal nitrite, which is being heated to give us the metal nitrite plus oxygen. So it is hard to reduce this one into the metal. So it is giving us another compound, metal nitrite plus oxygen gas. However, for this one, W nitrate, when heated, it is giving us W, the nitrite, and then oxygen. So this means that this W is a less reactive metal, and it is easy to reduce by heating into the W. Into W. So let's go and see now how we can answer, having informed you of this information. So when we go to A1, where they are saying which one of the three metals is the the most reactive. So between the two, the most reactive one is X here. So let's see how we can begin answering. Yeah, so we are here, the most reactive. So see, A1, I'm saying X. So the reason is here. This is because the nitrates of very reactive elements are hard to reduce to their metals on heating. Then part 2 here, I said, part 2 it is W, which is less reactive. And the reason is that this is because the nitrates of less reactive elements easily reduce to their metals on heating. So let's go to B. B says, which one of the three metals is likely to be sodium? So this one eliminated because this is wrong. So between the two, so reactive metals are found in group what? 1. So since they're found in group 1, so between the two, X is the element or metal likely to be sodium. So we'll say B, X. Then let's create a space here and then bring the question here. So see, they are saying which one of the three metals is 1 most reactive than zinc? Give a reason for your answer. Of course, X will be most reactive than zinc because it is even in group 1. However, I said like this, see, when I said X, and the reason was that this is because the nitrate of element X reduces to nitrite and oxygen gas. This is a characteristics or this is a characteristic of group 1 elements which are more reactive than transition elements to which zinc belongs. So zinc is a transition element, so it can't be more reactive than a group 1 element. Then part 2 here, where they're saying less reactive than zinc. So between W and X, actually it is zinc. I mean W, which is less reactive than zinc. The reason being here is that when this one it is heated, it gives us the metal and the nitrogen dioxide and oxygen gas. But however, the nitrate of zinc, when it is heated, it gives us the zinc oxide, nitrogen dioxide, and oxygen gas. So this one meaning it is less reactive. So the reason I had to put here was that this is because the nitrate of element W reduces to its metal on heating, but the nitrate of zinc does not reduce to the metal on heating. So now the last part here is state the chemical test for oxygen gas. So the chemical test for oxygen gas is that oxygen rewrites a growing sprint. So guys, if you are finding value in this video, please give it a like. I will appreciate, and also let me know in the comment section. So let's go to C2. C2 says 8.0 grams of impure sodium hydroxide C2, 8.0 grams of impure sodium hydroxide solution reacted with exactly 40.0 cubic centimeters of 2.0 mole per cubic decimeter sulfuric acid. A1, write the balanced chemical equation for the reaction, include state symbols. 2, construct a simplified net ionic equation for the reaction. Then B, calculate the number of moles for sulfuric acid that reacted with 8.0 grams impure sodium hydroxide. C, find the mass of pure sodium hydroxide from the solution that reacted with 40 cubic centimeters of sulfuric acid. D, determine the percentage purity of sodium hydroxide. So let's begin answering this question. So I have squeezed it here so that we can have space here. So I'll say C2, A1. So we are writing the balanced chemical equation for the reaction. So for the reaction between sodium hydroxide with sulfuric acid. So we need to write the formula for sodium hydroxide, which is NaOH. So since it is solution, we put aqueous here, because I've said include the state symbols. So these are state symbols. So it is in a solution, meaning it is in aqueous state, plus Then sulfuric acid, it's always in solution here because they have told us the concentration. So it will be H2SO4 aqueous. So remember, this sodium hydroxide is a base and the sulfuric acid is an acid. So these two, when they react, they will give us a salt and water. So they will give us a salt known as sodium sulfate, and it will be in aqueous plus water, which will be in liquid. Now they've told us to balance this one. So for us to be able to balance, we must inspect how many atoms of sodium are on the reactant side. So we have 1 atom of sodium, but on the product side we have 2. So we have to introduce a 2 here. So when we put a 2 here, we'll make the number of atoms of hydrogen here to be how many? 4 plus this here 2. 2 here plus this 2 here 4. Then when we come here, we have only 2. So for us to balance this, we must also put a 2 here so that we have 2 times 2, 4 hydrogen atoms, and here 4 hydrogen atoms. Trust me, it is balanced here. All right. So part 2 says construct a simplified net ionic equation for the reaction. So for us to be able to write a net ionic equation, we must split the species or reactants that are in aqueous state and also products that are in aqueous state. So like sodium hydroxide must be split here and write its ions or write its compounds as ions or its atoms as ions. So these two here is being shared by these. So when we split in between here, we have sodium. So we'll start with 2. Sodium ion has a charge of 2 aqueous, plus, then aqueous, then plus. So since we split, we'll say plus, this other side remaining, it will also carry a 2. So this side remaining is a hydroxide, which has a charge of -1, aqueous also this one here. Then we'll come to this plus, then we'll split this one, it will be hydrogen ion. So since there's a 2 here, we'll put a 2 in front of the hydrogen ion, which has a charge of plus. Then we'll put aqueous, then plus the sulfate ion, which has a charge of -2 aqueous. Then from there we'll write the arrow. Then this one also split it like there. So when we split in between, we'll say 2 sodium positive aqueous plus the sulfate aqueous, then plus water is not in aqueous, so it will remain the same. It is in liquid. Then what we do from here is we cancel out species or ions that appear on both sides of the equation. So we have sodium here and we have sodium here. These must be cancelled. Then we have the sulfate here and the sulfate here must be cancelled. So what we are remaining with is the hydroxide ion. So 2 hydroxide ion aqueous plus 2 hydrogen ions aqueous. These are the one giving us 2 molecules of water, liquid. Realize we have 2, 2, 2. So these 2 can cancel out. We remain with 1 more of hydroxide ion aqueous plus 1 more of hydrogen. Hydrogen ion, yes, aqueous, which will give us 1 more of water, liquid. So this is the net ionic equation. That's how we derive them. However, they just give 1. I assume they should have given 2 marks here. So we are going to move to B, where they're saying calculate the number of calculate the number of moles for sulfuric acid that reacted with 8.0 grams impure sodium hydroxide. So let's create space here and let's put the question here. Yeah. So we are going to calculate the number of moles of sulfuric acid that reacted with 8.0 grams impure sodium hydroxide. So we had this 8 grams of impure sodium hydroxide solution reacted with exactly 40 cubic centimeters of 2 mole per cubic decimeter sulfuric acid. So there's a word exactly here. So this exactly reacted, meaning everything here got finished. So we need to know how many moles were there in this amount of sulfuric acid that reacted completely with this. So we know for us to be able to answer this one, which is B, we'll say B, we must know the formula which connects volume and the concentration. And this formula is the concentration formula, which says concentration is equal to number of moles over volume. So C, concentration, any number of moles, V, volume. So we want number of moles because they are saying calculate the number of moles. So make number of moles the subject of the formula. So if you don't know how to change the subject of the formula, click on the video in mathematics whose link is appearing here. I already taught how to change the subject of the formula. So learn from here. So making N the subject of the formula, it will be N is equal to concentration times V. So let's have our data here, the information, because for us to know N, we must know concentration times volume here. So we know number of moles is what we want. Then we are provided concentration is equal to 2.0 mole per cubic decimeter, this one here. Then we are given volume is equal to 40 cubic centimeters, this one here. But when we are calculating concentration or number of moles, we don't use volume in cubic centimeters. We change it in decimeter, cubic decimeters, or liters. How do we change? By dividing it with 1,000. So by dividing this with 1,000. So we divide 40 by 1,000 to get the volume 0.04 cubic decimeters. So this is now the actual volume we are going to use. So next we'll substitute. Where there's concentration here, we'll put 2.0. Where there's volume, we'll put this. So say number of moles is equal to 2.0 times 0.04. So number of moles is equal to this times this will get 0.0 0.08 mole. So this is the number of moles of sulfuric acid that reacted with 8.0 grams impure sodium hydroxide. So we have found the answer. If you are finding value in this video, guys, give it a like. I will appreciate if you haven't done so, because you just click there. It's for free. It doesn't cost you anything. And if you haven't subscribed and you want the content, please consider hitting the red subscribe button there and turn on the bell notification. Also, it is for free. You don't pay anything. All right. So thank you very much, guys, for that, for your support. So let's go to another question, which is the question number C. Find the mass of pure sodium hydroxide from the solution that reacted with 40.0 cubic centimeters of sulfuric acid. All right, so let's clear the space here and maybe let's put the question here. All right, so what we are going to do here, guys, is that we know that this is the number of moles of sulfuric acid. So for us to be able to answer this question here, find the mass of pure sodium hydroxide from the solution that reacted with 40.0 cubic centimeters of sulfuric acid. For us to be able to know, because there is a way that I've said, find the mass of pure sodium hydroxide. Since we are given 8.0 gram of impure, we don't expect everything here 8 to react. Only the pure part will react, and that's the one they want. That pure part which reacted, because this is 8.0 of impure sodium hydroxide solution. Then they are saying find the mass of pure sodium hydroxide from the solution that reacted with 40 cubic centimeters of sulfuric acid. So only the pure part reacted, the other part never reacted. So they want that part which reacted. So how do we know that part? That part can only be found from the equation here. And then by using this value 0.08, take note 0.08 mole is the number of moles of what? Of sodium, of sulfuric acid. We'll use it. So in answering this question here, C, here, we'll say C, we need to create a more-to-more relationship. A more-to-more relationship between this and this. These two which reacted. So there's a 2 here, take note, there's a 1 here. So what we are going to say here, we will say number of moles of sodium hydroxide over 2 is equal to number of moles of sulfuric acid over 1. Where are these coming from? That equation, in front of sodium there was 2, in front of sulfuric there was nothing, that means there was 1. So this one is read as number of moles of sodium hydroxide over the stoichiometric mole ratio. So these two stoichiometric mole ratio. Then number of moles of what? Of sulfuric acid over 1, which is a stoichiometric mole ratio in the balanced equation. So what we are interested here is to find the mass of pure sodium hydroxide. For you to be able to know the mass of pure sodium hydroxide, you must calculate the number of moles of sodium hydroxide in this reaction, the ones that reacted, and they are the ones that will help you to calculate the mass. So from here, what do we know? We know the number of moles of sulfuric acid, which we just calculated here, which was 0.08 moles. All right, so from here, we are going to make a number of moles of sodium hydroxide the subject of the formula, which will be any number of moles of sodium hydroxide equals, so this will be here 2 times number of moles of sulfuric acid. Then we know that we have, we'll say equals, this one equals, we know 2 times the number of moles of sulfuric acid we already calculated, which was 0.08. So say 2 times 0.08, which will give us number of moles of sodium hydroxide equals 0.16. So you have seen the importance of this mole-to-mole relationship. It is able to give us an ability to calculate the number of moles of this. Very simple like that. Then from here, now we know the number of moles of what? Of sodium hydroxide. Now we can know the mass using this equation. Number of moles is equal to mass over molar mass. You can click on the video here, introduction to more concept, to understand what I'm doing here. So number of moles is equal to mass over molar mass, but we want mass. Find the mass. So we want mass, we make mass the subject of the formula. It will be mass is equal to number of moles times molar mass. So now, what we are going to do is, this number of moles of sodium is already here. Then this molar mass of sodium is 40. So on the link you will click here, it will show you how to find the molar mass of sodium hydroxide. So it is 40. So you say mass is equal to number of moles, you put 0.16 times molar mass of sodium 40. When you multiply this, you get 6.4 grams of sodium hydroxide. It's the one which reacted. So you were given this, but only this reacted according to that equation. All right, so if you are finding value guys in this video, please give it a like and let me know in the comment section. All right, so let's move to another part. So part D says determine the percentage purity of sodium hydroxide. So they need percentage purity. So you should know that percentage purity is given by mass of pure substance divided by mass of impure substance times 100. And you must remember here is that 8.0 grams of impure sodium hydroxide is the mass of impure substance. And the one we have just calculated in C is the mass of the pure substance. So we'll say percentage purity is equal to 6.4 grams, the one we calculated because that was the mass of pure, divided by this, the mass of impure, which when you evaluate this, you get 0.8 times 100, you multiply, you get 80% as the percentage purity, meaning 20% is impure, then 80% is pure. Okay, So let's go to the other question, the last question here, which is the C3. C3 says the series of processes below show the links to the formation of an ester known as ethyl ethanoate. So we have an ester, process K giving us ethanol, process L giving us P, process M giving us ethyl ethanoate and ester. Then they're saying from the reaction scheme above, name process K, L, and M. Then B, construct the chemical equation for construct the chemical equation describing process K. Include state symbols. C, state both the chemical name and the common name for substance P. D, state the general formula for the series where substance P belongs. Then E, give any two uses of ethyl ethanoate. So let's start with this one. So what you should understand is when you have ethene to change to ethanol, this must be a reaction known as the hydration. So when ethene reacts with water, it must give us ethanol. Then this ethanol here, it reacted with another substance to give us another substance which they haven't shown here. So which substance did this ethanol react with? So ethanol must have reacted with oxygen oxidation to give us an acid here. This P was an acid. So this an acid now, it is the one which reacted now with another substance here to give us what? To give us ethyl ethanoate. So now they want this process, ethene to ethanol. So I said the hydration here. So ethanol to another substance which will lead us to ethyl. So ethanol must go to an acid. So this process must be oxidation to form an acid. Then an acid to give us ethyl ethanoate must have undergone esterification, which must have been the reaction of an acid with an ethanol or an alcohol to give ethyl ethanoate. So what we are going to say is that C, A, we are saying process K is hydration, then process L here is oxidation, then process M is esterification. Then B, they are saying construct the chemical equation describing process K, include the state symbols. So process which one? K. So we'll write ethene. So see, ethene is C2H4. It is a gas plus then water, which will be in gaseous form, equals. So this one now will give us the ethanol, which is this one here, ethanol. It will be liquid form. All right. So now they're saying this must be balanced. When we check here, 2 atoms of carbon, 2 atoms of carbon, 4 atoms of hydrogen plus 2 gives us 6. Then here 5 atoms here plus 1, 6. Oxygen 1, oxygen 1. So it is balanced. Then we go to C, state both the chemical name and common name for substance P. So this substance here, which was formed by the formation of an alcohol, when it undergoes, this alcohol undergoes the oxidation. So it will be ethanoic acid here, because they are saying state the chemical name, ethanoic acid, and the common name of substance P. So it will be acetic acid. So say, see, the chemical name of P is ethanoic acid. Then the common name of P is acetic acid. Then let's come back. They are saying D, state the general formula for the series where substance P belongs. So P here, it's an acid. So an acid, this one, it is given by Cn-1 H2n-2 COOH. So this is the general formula. Then E, they're saying give any two uses of ethyl ethanoate. So ethyl ethanoate is an ester. So esters have these uses: one in making perfume, two in food flavoring. So guys, we have come to the end of this video. Please, I beg, give me a like, and please support my channel by subscribing to it so that you expect more videos of this kind. All right, so I appreciate for watching and also for subscribing and for liking. As for now, we have come to the end of the video. Until next time, please, peace.